Hello and welcome to today's IWCS webinar. My name is Connie and I'll be your Cisco WebEx producer for today's event. We have a few housekeeping items before we get started. If you experience technical difficulties during the WebEx session, please dial 1-866-779-3239, or you can message me using the Q&A panel. Please note that as an attendee, you are part of a larger audience, and during the presentation, all participants will be in a listen-only mode. As a reminder, this event is being recorded for rebroadcast. We encourage you to submit written questions at any time during the presentation using the Q&A panel located at the bottom right of your screen. After typing your questions in the space at the bottom, hit the send button, and please be sure to direct your questions to all panelists in the Ask menu. Your questions will not be seen by other members of the audience and will be addressed, time permitting, at the end of the presentation.
Thank you, Connie. Our IWCS webinar series event is hosted by the International Cable and Connectivity Symposium. I am Ed Fenton, a cable industry advisor working with the IWCS team. As Connie said, if you have questions, please use the Q&A box on the bottom right of your screen to post a question anonymously. If you wish to contact the presenter or IWCS after the presentation, you will be given the contact points at the end of the webinar. Please note that IWCS does not distribute the presentation slides from either our conference sessions or these webinars. However, please feel free to contact the presenter directly and they will respond individually to you. Today, we welcome Patrick Van Vickle, Director of Research and Development, Sumitomo Electric Lightwave, North Carolina, USA, who will be presenting his paper on ultra-compact indoor optical fiber cables and applications. Pat Van Vickle serves as Director of Research and Development at Sumitomo Electric Lightwave. He received his PhD in Mechanical Engineering from North Carolina State University with a dissertation titled Photonic Band Gap Fibers for Transverse Strain Sensing. He is also a licensed professional engineer in the state of North Carolina. Pat, we welcome you to present at today's IWCS webinar series event.
Well, thank you very much, Connie and Ed, for the opportunity to come here today and present this paper again. It was very well received, and I look forward to presenting it to a broader audience today. And again, my name is Patrick Van Vickle, and I am the Director of R&D here at Sumitomo Electric Lightwave. But I have to mention that a lot of the work that's shown here, of course, was not my own. It was the other co-authors here and many other people, including Dean Dancy, who's in process engineering, along with Jeff Truckner and Lauren Rapp, who's a product manager here at Sumitomo. So I must acknowledge they had a great deal to do with everything that I'm about to present. So I wanted to start with an outline, basically discussing today's paper, and start with an introduction of why we're here today, why we undertook the work that I'm presenting today, and then go into the resulting cable and ribbon designs that were made necessary by the kind of the challenges that we were getting by some of the industry. And that involved the development of and use of a new type of ribbon, which I no doubt is pretty common now in the industry, and people are aware of it. We call it pliable or trademark freeform. You might also see it in the standards under other names. And then a unique cable design. And following that, I'll go over some cable qualification results. And not spend a ton of time in that, but there are some national standards that are applicable for cables in general. And then one of the things that goes beyond just the cable design itself, but often comes up when we discuss anything new, especially these new ribbon designs, is how to work with them. So we're going to talk about ribbon splicing and how that's accomplished. And what turned out to be a much larger part of this paper and actually this project and this entire undertaking than I ever anticipated when we first started work on these entire product lines that I'm describing was all the associated network hardware that had to go along with them that just didn't exist, and we had to create it. So talk about that a little bit, and then finally conclude, and take some questions. So to start with, and I don't mean this to be in any way a kind of a training course on data center design. I couldn't ever hope to begin to even try to do that. But basically, in broad terms, the modern data center fabrics and how they're set up now is just much different than some of the work that was 10, 15, 20 years ago, maybe even 5 years ago. So there's just some different ways of setting up data centers now. And they used to be, kind of what they called skinny tree, where you had a very hierarchical structure of fiber that went north and south, but there wasn't a lot of cross connects between different parts of the data center or how the typical data centers were designed. But there was some discovery of some types of constructs that have kind of been utilized now. Folded closed networks, a fat tree, they come under a lot of different names. And the exact designs, of course, vary from different provider to different provider in the hyperscale world, and I'm sure they're very proprietary. But the main takeaway here is that they do not have just single connections running north and south from servers to switches and up and down. They have cross connects across all different levels, and many of them, many-to-many type connections. So because of that, basically you've got hundreds of thousands of connections and maybe more. And what makes this, one thing would be if all of these connections existed within maybe a data hall or even inside of a data center building. But because of the way these are being implemented in the real world, these connections may actually cover a geographically diverse distance, and that could be up to miles. So you could have, going from hall to hall or across a building, but you could have going to a pod on the campus or another building on the campus. But in some extremes, you could have those connections, these many thousands of connections having to be made to entire different campuses that are way far apart from one another. So because of this new way of doing data center construction and the fabrics that are being set up, the cross connects, that's one thing. But again, the geographic diversity of it really kicked in a new problem. And I'll describe the problem in the next slide. And that is that especially when if you're on your own campus, it's not a problem. But if you're transversing a large geographic area, you're no doubt going to have to deal with public rights of way and existing infrastructure that's there. And so, as many people are probably aware, laying a new duct bank that goes into, across a road or railway or whatever is not an insignificant thing to do. And so one of the things, too, is that what the existing duct space that's there is, especially in some parts of the country where it's relatively a tight supply of that, I was staggered to learn some of the costs, on an annual basis that are associated with renting just a small, duct. So what you run up against is that you have these new data center fabrics with hundreds of thousands of connections that have to be done, sometimes over public rights of way, yet the infrastructure is not there for that or was never built for it. And so you have to start running mini cables using extremely expensive duct bank. And so there was no good way to handle that. And I'm showing here in this picture a public domain photo that I was able to find, or at least one that was available openly in reference there to kind of show a picture. But basically, you can imagine that there are these very small areas with a certain limited diameter that is very restrictive. I mean, it is what it is. And unless you plan on running more of your own, those small diameters are what you have to work with. And now you've got a lot of fiber that's got to get through there. And the expense of renting more and more duct bank, if it's even there to begin with, is just enormous. So you're left with the challenge of you want to have a geographically diverse data center setup, and you need to get fiber from one place to the other, and yet you have this huge constriction point right here in this duct bank going from one place to the other. So that was kind of one of the main motivations of the outside plant side of this. But when you get to the inside, you don't have exactly the same problem, and that, certainly if you own a large data center or a co-location facility, you have a lot more control over what that looks like in terms of, your cable routings, your ladders, your cable trays, and, of course, your duct banks on the inside when you're running from building to building. But nonetheless, you still don't want to have a large amount of cabling that's unnecessary. It can certainly be hard to manage. And one of the things we found was that if you have a large high fiber count cable that is coming from the outside plant that's entering into a data center building, you'd much rather slice that cable to another high fiber count cable rather than run hundreds or whatever it might be of these smaller fiber count cables out from that one cable. So there's a number of reasons why this desire to have this ultra dense cabling infrastructure to be able to fit through these ducts in the outside plant also translated in a way to having a higher fiber count cables on the inside plant. So that's kind of the problem statement. That's where we started all this years ago. This was kind of the industry issue, the problem we were trying to solve. So the way we do that is implementing what we're calling in this presentation pliable ribbon. And again, it has different names. There are certainly some trade names for it. Sumitomo's is freeform ribbon. In standards work, you'll see names like partially bonded ribbon or ribbon with intermittent attachment points. Those are some common terms you'll see in the standards. But this ribbon has the feature where you can essentially collapse it into more of a round structure when you want to put it into a cable, but then you can lay it flat again and splice it to either itself or to another flat, traditional type ribbon. So it's kind of the best of both worlds. It's always been kind of one of the less desirable features of flat ribbon, especially in like cordage when you had a preferential bend plane because it was a flat ribbon, but this solves that problem. So it also solves the problem of the ability to, you had a lot, if you look at a traditional flat ribbon cable, you had a lot of empty space in the tube just because of the square and a round structure or whatever you were using, and this solves that problem. So you get into a lot of efficiencies we'll talk about in a minute. And then, of course, there's a number of different implementations of this type of ribbon in the industry from different vendors. Sumitomo, being a splicer manufacturer, was kind of aiming at the splicing part of this from the get-go and working tightly with the splicing group to make sure that the way in which the ribbon was constructed was optimized to make it easy to splice to either itself or to a conventional ribbon. And I think that's one of the things that really stands out about this ribbon is the fact that it's easily spliced and it was optimized from the get-go for that, which is, I think, you'll find not necessarily true across the whole plane of these types of ribbons. And again, the idea here was that, for installers, we don't want someone to have a new tool or glue or anything weird in order to make this work with conventional ribbon. So the idea, again, was to splice with no glue or special tools or anything for that. So that's the ribbon. Now we're moving into the cable. And as I mentioned before, you see that we had flat ribbon structures, which do still have a place in the industry and do have some places where they're certainly applicable. But they do, as you can see in that top image there, have a lot of open room in there that could possibly be used up, and it's a little bit inefficient. So because these ribbons can collapse like this and you can form bundles, you can take essentially what used to be, in this case, I believe it's a 288 down from 20.5 down to 15.7. And actually what we're really seeing is that once these cables are more optimized, which this is kind of a first generation diagram I'm showing here, you actually take about half your cable. You about half the size of your cables from a flat ribbon down to these pliable ribbon structures. So what's shown here on the top is a 288, and then the bottom is a 1728, which is a very common size for this type of indoor cable. And again, that 25.6, roughly an inch diameter of that cable, it was essentially an 864 size if you were in a flat structure. So we had an 864 riser that was about that size. So you see you doubled your fiber density there from that. And that makes for smaller ribbon or smaller cables in your cable trays. And again, if you're running into a building and you're splicing to an outside plant cable that's probably quite a bit bigger fiber count than that, you'd rather have maybe 4 cables you have to splice to that, or 6 cables you have to splice to your outside plant rather than 12, 15, or whatever it is if you use like a 288 or smaller count size. So that was kind of the cabling genesis of this. Was the outside plant was really driven by that restriction in the duct banks and the cost of leasing or putting in new duct banks in public rights of way for these new data center designs. But it flowed downhill from there. And the next stop on that kind of, if you think it through, the entire start to finish part of the infrastructure was this indoor cable. So we immediately rolled this out. We realized that very early on. So that was kind of the genesis of those two cable designs. Now, I don't plan on spending a whole lot of time on this. I just wanted to kind of show it from a due diligence perspective that there are cable standards. There's ANSI national standards that apply to all different types of cable. This one is ICEA 596, which was the indoor cable standard. There's other ones for outside plant, indoor, outdoor, and so on and so forth. But we qualified the cable to the ICEA 596, and there's more details about this in the paper, but basically it passed all the requirements, and as all our cables do, including the fire resistance and all the other mechanical and environmental requirements. So moving on to the specialized components for this. So as I mentioned earlier in the presentation, what caught me off guard a little bit in the design side of this was that the need was very clear for the reasons for the cables I mentioned before. But what we very quickly found out was that the hardware that was in the industry at the time was not up to the task of handling these kinds of cables, both from the structure of the cables, but mostly from the fiber counts. Just the sheer fiber counts were just enormous compared, and there weren't closures, there weren't interconnection devices out there that could handle this. And so it really kicked us off into a whole design cycle to look at the entire network from start to finish and try to make sure all the components were necessary to fulfill that need. Luckily, in combination with design work we do here, I'll show some hardware products about that, and also the closure development work was done. That we've been making closures for a long time in Japan, so it was a collaborative effort there to bring all these pieces together so that the entire system would be covered for these types of cables. I'll start by talking about the splice closures. So again, when you've got a 3456 or a 5184 or now 6912 cable coming in, and you either need to branch splice it or butt splice it to another cable, there just wasn't anything out there to do that. It just did not exist. So Sumitomo had cases, as did I think other manufacturers, for lower fiber count cables, but again, nothing for this volume of fiber. But they turned their attention to that and came up with a couple of kind of innovative ways of doing things to make those closures not, twice or three times what you're used to, but kind of more in line with the standard closure size. And they came up with some very interesting ideas, including these risers, which are kind of shown a little bit here in the left-hand picture, where you kind of can raise the entire deck of splice trays up to manage the slack underneath, and then the trays are decked like that to make the easy access where you can slide one over, kind of fan it out to get to which card you're interested in. So there was a lot of work done to have this happen, and it was very important because some of the runs of these outside plant cables were longer and entered in areas where you would have to have a splice, and you had to have a splice closure to be able to handle that. So that was one of the first things that we had to look at. But again, when you've got this outside plant cable, it's being spliced, but eventually it's going to enter the building. And again, we realized that, when you're transitioning from an outside plant cable in a building and you have to go to a fire retardant cable to go into the building, either a riser or a plumb cable, you have to have some facility to do that. And again, there just wasn't anything in the industry that could handle the volume of fiber and size of the cables that we're talking about. So here in North Carolina, we developed this ultra hyperscale exchange box, this interconnect box, and it has the capacity for 41,472 fibers, or a number of 6912 cables coming in. And it allows you in a very kind of organized way to manage the cables transitioning and being spliced to their inside plant counterparts. So what's shown here in this photo on the right is a little removable splice tray that holds your splicer and all your tools while you're doing the work, and moves up and down with you as you go. And then on the right-hand side, the cables enter either from the top or bottom, and then come around those kind of spools that you see there, and then move around and transition into the trays where they're spliced. And then you can see on the left-hand side, there's cables exiting and the ports there, and those, of course, are fire retardant, in this case, riser cables, I believe those are. And the fiber count, originally those fiber counts of those cables, again, were like 288. But again, it's migrated up very far north of that now. So, but we needed some device, some way to easily manage this kind of fiber volume. And so this device, the ultra hyperscale exchange box, was designed for that purpose. So the next thing that comes up, and when you're in, you actually have to do the transition of the splice, whether it's in a closure or it's in a hyperscale exchange like at the building entrance. You've got to figure out how to splice. And again, we focused a lot on that from the very beginning to make sure it was covered. And just to illustrate why that might have not been obvious for someone in the beginning, the top ribbon there shown where you can actually read Sumitomo, that's a traditional flat ribbon. And it has a name printed on it, a color designation that kind of identifies the number along with the number itself and what type of fiber it is. Well, when you look at the bottom there, you can see that's a pliable ribbon, and in its natural, kind of unflattened state, what it would look like just laying there. And so you can see that there would be a challenge in splicing those two things together. And so it turns out, though, that the way in which you make that pliable ribbon and how you control the contact points and how the pitch of those are and so forth plays an enormous role in guaranteeing that you have good splicing. And so moving on to the next slide, you can see traditionally, if you're at all familiar with ribbon splicing, it won't look new to you, but basically you have to load that into a clip, which then it gets stripped, cleaved, and put into a splicer. And the steps are very similar, whether it's a standard flat ribbon, which is shown on the left, or a pliable ribbon on the right. There is an additional, attention that you have to pay when you're loading it into that clip. And I'm not going to lie and say someone who's never done it before is just going to do it the first time, but it's kind of a tactile feel that once you do it a couple times, you have it, and you're up to your speeds that you would be with the flat ribbon. So it's just a matter of making sure that ribbon lays flat in there before you close the door, and then the steps are the same. But again, getting to the point where you can do that and lay that in there with that ease, without a glue, without a tool or anything else, but have that work out for you on a repeatable basis is a function of that ribbon design. It wasn't something that came just naturally; it was worked on. But then again, once you're put into the clips, you go through the very same steps you would with a flat ribbon. And shown on the top and bottom here, you see a pliable ribbon on the bottom, and then the flat ribbon on the top. So you go through, and the ribbon is cleaved or stripped and cleaved, and then it's put into the splicer. One other thing that came along a little bit later, if we go through the entire infrastructure, is that we've now got a cable that's in the outside plant. It's moved to the inside plant and gone through a hyperscale exchange to a flame retardant cable. But now that has to go from the hyperscale exchange somewhere else in the building. And one of the things that's requested and came out of this was a way to rapidly deploy from there. So what's shown here is one of the things that came out of that development work, which was essentially what you see in there is an 864 panel that's been preloaded with fan outs and spliced to a cable, which is what that yellow cable is there, an 864, on that reel. And that reel, it's kind of difficult to see, but it's on a set of rollers on a pallet. So once you remove the chocks from that reel in the data center, you essentially just start pulling on that cable, and then goes into the hyperscale exchange. When you're done, you open the side of the reel, pull the panel out, put it in your rack, and everything's ready to go. So this is one of the things that, again, I personally certainly did not envision this structure or this type of device coming out of that very early development work with some of the outside plant and inside plant cables, but this has been something that's come out of that work. So we had to really take a soup to nuts, start to finish approach and kind of look at the whole thing from scratch once the need was there. One of the things that came out of that too, going to the final step kind of before when these cables are delivered, is how do you manage, again, you've got these really high fiber count cables, and this is sometimes 864, 1728 inside plants coming to a rack. So again, we had to come up with, there was nothing out there to deal with that. There was nothing that existed. So we came up with basically numbers of different devices in order, depending on what the customer wanted to do with that, including pre-terminated 864s and 2RU denominations, which is the top right picture there. And there's a breakout there that handles in a nice, easy way those fibers coming from a higher fiber count cable fanning out into there. And in cases of larger count cables that want to do a different kind of separation structure, the picture there on the right shows a box which was designed to handle that. And then on the bottom right, we had to come up with the fact that perhaps someone wants to gang together lots of panels using very high fiber count cables, and we needed a modular approach to do that. So we actually have a transition box that's made to basically daisy chain down a rack in order to distribute fibers to panels. So we've got the fiber now all the way delivered to the panels, and then the panels themselves were designed for some specific design constraints to make the connections easier there too. So we had to kind of start from the outside and work all the way into the inside and design all the way. So in conclusion, I just wanted to stress that the architecture has evolved and the level of connectivity went up dramatically. But the space available for the cables to do all that connectivity wasn't there. It didn't grow at the same rate when this explosion happened or this change happened in the way that the data center structures were changed. So you were left with this problem. And that space limitation really necessitated the need for these new cables. And we had to come up with a way to basically put more fiber in a smaller diameter. But we had to do that in a way that the installers could still use it, and the splicing was still there, and we had to pay attention to all the same cable parameters that you would in terms of the standards and everything else. However, what we didn't initially think of, but was quickly made evident to us, was that the introduction of these cables basically necessitated an entire ecosystem around them to have to be designed and evolved. It just didn't exist. We couldn't say to our customers, hey, go see vendor X for this or vendor Y for that, because it just didn't exist. So we had to come up with a whole series of cables, enclosures, and entry exchanges, and rack mount panels, and deployment techniques on reels, as I showed, and an entire system, really, to get this to work as a whole. Now, since this presentation was given, or actually even there, I mean, there's been a lot of other developments. You know, some of these same technologies, like the cable designs with pliable ribbons, have started to migrate into more traditional cable spaces. And there's plenums and risers and low smoke halogen frees and things that we offer in those cables that are much smaller in fiber counts, more traditional kind of premises fiber counts, and the 288s and 96s and so forth and so on. But again, that has the original drive for all this work came from this new structure, but now that's flushing its way through kind of the entire cable market down into the enterprise side as well. So it's an exciting thing to watch. So that's pretty much it for me. I thank you very much to Ed and Dave and Connie and everyone for giving me the opportunity to present. And I guess we'll take some questions.
Very good. Thank you, Pat. At this time, we will ask as many questions from the attendees as time permits, starting with this first question. Are there any adverse attenuation or performance issues with ultra-compact ribbon fiber cables relative to conventional round cables?
No, I can't say there is if you make it right. We haven't seen that. And I mean, to be fair, I can understand when someone is used to seeing a relatively empty central tube with some flat ribbons in it, and you're presented with a cable that has a pretty densely packed amount of fiber in it. It would be a natural question to ask, and one that as manufacturers that we definitely were paying attention to. But we monitor both, you know, through the standards, which the qualifications, of course, temperature cycling and so forth, but also at the manufacturer point, the distributions of attenuations as they come off the line. And I wouldn't say you're going to see any difference there.
Okay, thank you. Next question. For indoor North American data center applications, is the cable fire rating based on either riser or plenum requirements?
Yeah, that's a good question to ask. There's a way to answer that. It's what the customer wants, and then, of course, what the fire code requires in a specific area, and then there's kind of what the insurance company that the data center has enlisted wants, and so those are all different answers. But we're seeing a lot of riser in that, but there is plenum out there as well, depending on where in the data center. So there's just not one good answer to that, unfortunately, but it's definitely a good question to ask.
Okay. Next question. Are ribbon fusion splicers readily available and now standard practice in the field or data center?
Yeah, so of course the 250 micron based ribbon splicers, you know, have been around for a long time. Of course, Sumitomo is one vendor, but there's others, and it's a mature market in a lot of ways for those. And those same splicers and same like clips and accessories for those splicers will work with this ribbon. Now, there's a broader question, and may have been the one at the root of that question, which has to do with the advent of 200 micron ribbon, which is also coming and is out there, and we have. So there's splicers made specifically to deal with that, and there's also a way to, if you have a 250 to 200 pitch ribbon, to splice one to the other, and a heterogeneous splice, and there's a way to handle that as well. So all those different types of splicers exist and are out there. The degree on the 200 micron or 200 to 250 stuff I just mentioned with other vendors I can't really speak to, but I know that we've got that one figured out. So.
Okay, great. Thank you. Next, do you know the production speed of 12F rollable ribbons in comparison to standard 12F fiber ribbons?
Yeah, I'm going to have to put that one under, even if I knew that exactly off the top of my head, I think that would probably be one of those proprietary secret sauce questions I probably wouldn't be allowed to answer. So, yeah, I think the answer my marketing people probably want me to say is that we can make it as fast as you want to buy it, but that's probably all I'm allowed to say about that.
Okay, very, very good. Very good, thank you. Is there a need to have less bend-sensitive fiber in these designs versus standard cable?
It certainly gives you some benefits, and I think, but to be honest with you, if most of the Tier 1 fiber suppliers and cable suppliers will transition to 100% bend insensitive anyway. Even if you were to buy a flat ribbon cable product from us today, and I think this is true of any of the, like I said, the North American kind of Tier 1 cable makers, you're not going to get a non-bend insensitive fiber anymore. Everybody's got a 657A1, 652D compliant fiber as their standard fiber now in cables. At least we do, and I'm pretty sure most everybody else has kind of moved that way too. So the bend insensitive fiber in these structures, I'm sure it does help you just like it does in a flat structure. It gives you just a little bit more margin for, you know, if an installer or a routing of the cable is a little more aggressive than maybe what would be recommended. You kind of get a little bit of more room to play there. But that type of fiber is not unique to these cables. It's now been kind of rolled out across the board for everybody's cables. So that's kind of where that sits at the moment.
Great, thank you. Next, is there a requirement for different fiber holders or sleeves? Any other specifics for splicing?
Not for 250. And again, I didn't really go in this presentation much to the 200 micron variants of these cables. That's kind of a unique market, which probably would appeal less to the enterprise and probably more to the hyperscale guys. But for 250 micron pitch ribbon, it's standard holders, it's standard splice sleeves. There's nothing different about that. If you, again, as I want to qualify that by saying that if you plan on splicing a 200 micron pitch ribbon to a 250, the ribbon's smaller, and when you go to splice that, there's a special clip you need on the 200 side in order to make that, you know, splice up well. But that's kind of a very unique circumstance for that. And then if you're doing 200 to 200, then you would use that associated clip. But for the base presentation here, the product shown here, there's no special splicing hardware required.
Thank you. Next question. The attendee asking the question, he or she saw a video that shows the splicing technique using glue to ribbonize the pliable ribbon before splicing. What are your thoughts?
Yeah, and some of the early work with this, and I think most of it was not us, but I think there was, I can't say for certain that there's not something out there in the early work of this that wasn't something that was shown to do. People even advertised that you basically had to strip the ribbon and re-ribbonize and so on and so forth way back when, and I'm talking years ago. But basically, I can guarantee you that for these ribbons and these cables that we're making, that again, we optimized that the split ratios and everything else in there between the pitches and the frequencies of those separations in the ribbon to make it to where you did not have to use a glue, and you don't use a glue, and people are not using glue now. So it's not kind of what the current practice is.
Okay, thank you. Next, what type of fibers are available for this product?
Right now, our focus is on single mode. Again, it's bend insensitive because kind of industries move that way. To be honest with you, I've never had somebody come to me and ask for a 6912 OM4. That would probably cost more than our plant here to make it. But right now, the focus is primarily on single mode because of the use cases for that. I'm sure if the market develops and they would like, OM5 or something that's of some fiber count, then that would certainly drive the development work for that. But again, the focus right now is on straight up 652D, 657A1, bend insensitive single mode.
Okay, thank you. Next, does the 200 to 250 have to be a pliable ribbon?
That's a good question. So it really depends on which one's pliable and which one's flat and how you do it. And to be honest with you, I know that the holder that I'm mostly familiar with, it helps if it's pliable, but there's ways that doesn't have to be. So that's kind of a more involved technical presentation that could probably be its own presentation in and of itself to describe kind of the challenges that we had to overcome to get all that to work right and how you do it. But I guess I would say it helps, and the easiest way to do it is if it is pliable, but there's other ways to do that. So it's kind of probably the easiest way to answer that question.
Thank you. Next, is there any plan for any of your ongoing activities in order to have multi-mode rollable ribbon cables available in the near future?
Again, I think that really depends on the use cases for that. So this whole effort, as you can tell, was driven primarily from a very high fiber count standpoint, and the people that are doing that work are focused on single mode. So when probably the business case and use cases are there for some of the multi-modes to be there for that, then that's where we would go. It's certainly something we look at. It's just it's not something that we focus on from the beginning.
Okay. All right, Pat, at this point, I don't see any other questions coming in. So I would like to thank you for presenting this very interesting and important topic today. Please note the contact points being shown should you wish to contact Pat after today's event. Each of these IWCS webinar series presentation events are recorded and will be archived on the IWCS website. It normally takes up to 2 weeks for these to be posted. The IWCS webinar series will conduct presentation events on a monthly basis. Webinar events will take place on the third Friday of each month at 10:30 a.m. Eastern USA time. Our next scheduled webinar event will be on Friday, July 20th at 10:30 a.m. Eastern USA time. Each of you will be receiving an announcement for the event a few weeks prior. Please feel free to share our announcements with your colleagues so that they can join in and register as well. For over 66 years, the IWCS International Cable and Connectivity Symposium has been the recognized leader showcasing new technologies in cable and connectivity products, processes, and applications. Our next annual international conference will take place on Sunday, October 14th through Wednesday, October 17th, 2018, at the Rhode Island Convention Center in Providence, Rhode Island, USA. In addition, the third annual UL and IWCS China Cable and Connectivity Symposium will take place on Tuesday, March 26th through Thursday, March 28th, 2019, at the Shanghai International Convention Center in Pudong, China. Please visit our website at iwcs.org for more event details. In just a moment, you will see a brief survey so that you can provide us your feedback and comments on today's event so that we can further improve this webinar series for you. Thank you for participating, and this concludes today's event.